Welcome to Star Technology 5G. In the last video, we studied how to enable timer 1 interrupt function. In today's video I will show you how to enable serial communication interrupt function. Let's start the video. Please subscribe to the Star Technology 5G and click on the bell icon. Enabling and disabling an interrupt function. All interrupts function are disabled by default, meaning that none will be responded to by the microcontroller if they are activated. The interrupts must be enabled by software in order for the microcontroller to respond to them. The INTCON register is responsible for enabling and disabling the interrupts function. Here is INTCON register. GIE, Global Interrupt Enable. PIE, Peripheral Interrupt Enable. TMR0, Enable Interrupt Bit. INT, External Interrupt Enable. RBIE, Port Change Interrupt Bit. TMR0IF, Timer 0 Overflow Interrupt Flag. INTF, External Interrupt Flag. RBIF, Port Change Interrupt Flag. Project, How to Enable Serial Communication Interrupt Function. In this project, we will connect LEDs with RD0 and RD1 pins of a PIC16F877 microcontroller, and we are using an 11.0592 MHz crystal. We will connect the LEDs in current syncing mode, and the value of the resistor is 260 ohm. We will connect TX output of the microcontroller RC6 pin and RX input of the microcontroller RC7 pin with a MAX232 level converter chip. The output of the MAX232 will interface with PC using DB9 pin type connector. If we will press 1 LED 1 gets turn on, and if we will press the 2 LED 2 gets turn on. Here is the circuit diagram we are using in our project. It is PIC16F877 microcontroller. Pin number 1 is master reset. If we press the switch it will reset the microcontroller. Pin RD0 and RD1 interfaced with LED 1 and LED 2. And we are using current syncing mode of LED. The value of the resistor is 260 ohm. Pin RC6 and pin RC7 interfaced with MAX232. Here is MAX232. These are capacitors interfaced with MAX232. The value of capacitor is 10 UF. The output of MAX232 is interfaced with DB9 pins connector and other side of the DB9 pin interfaced with PC serial communication. Pin numbers 13 and 14 interface with an 11.0592 MHz crystal. And 22 PF capacitors connected with the crystal. Pin number 11 and 32 connected with positive 5 volts. Pin number 12 and 31 connected with ground volt. Let's draw this circuit in Proteus. In prod use we do not need MAX232 IC. But in practical circuit you need MAX232. I will disconnect the MAX232 IC and I will connect the virtual terminal direct with PIC16F877. The circuit is ready now. We will write its code in micro C PIC. Here is the window where we can write the code. I already wrote the code, otherwise video gets very long. I will copy the code. And I will paste it here. Now I will define you the code. S-bit LED1 at port DB0. Define port D-bit RD0 as LED1. S-bit LED2 at port DB1. Define port D-bit RD1 as LED2. Unsigned char. REC. Define variable. Void interrupt function. If RCIF equals 1. If serial interrupt received. REC equals REREG. Copy receive character into REC. If REC equals 1. LED1 equals invert LED1. If received character is equal to 1. Toggle LED1. If REC equals 2. LED2 equals invert LED2. If received character is equal to 2. Toggle LED2. Void main. Main function. TRISD.RD0 equals 0. Set port D pin RD0 as output pin. TRISD.RD1 equals 0. Set port D pin RD1 as output pin. RCSTA equals 0x90. Enable serial port and enable continuous receive. TXSTA equals 0x20. Enable serial communication, low baud rate 8-bit. SPBRG equals 17. 9600 baud rate, XTAL equals 11.0592 MHz. INTCON equals 0xC0. Enable global interrupt and peripheral interrupt function. PIE1 equals 0x20. Enable USART receive interrupt. LED1 equals 1. Clear LED1. LED2 equals 1. Clear LED2. While 1. Stay here. Now we will create the hex file. Just click on the build icon. Finished successfully. File is created. Now we will load hex file into the microcontroller. Double click on the microcontroller. Select the hex file. OK. And click on the run simulation. Right click on virtual terminal and select echo type character. And press 1. LED1 get turn on. Now press 2. LED2 get turn on. You can see microcontroller stayed here doing nothing, but when it will receive the serial interrupt it will respond to the serial communication interrupt function. Again press 1. LED1 get turn off. Now press 2. LED2 get turn off. If you have any problem with the code, let me know in comments. Thanks for watching. Please subscribe to the Star Technology 5G. And keep watching Star Technology 5G.